Hello students and welcome back. Today we are tackling an organic chemistry question that looks a bit intimidating because of the stereochemistry involved in the products. I know many students tend to skip these or lose marks simply because they don't fully understand what the question is asking. That's exactly why I'm here. I'm going to show you how to break down the problem, approach it the right way, and secure those marks. Just follow my lead and let's get into it. First, observe the reaction conditions. The given reactant is an alkene, but it is unsymmetrical because there is a phenyl group attached over here. When this is treated with borane in THF, THF stands for tetrahydrofuran. This is a aprotic polar solvent. Then the second reaction condition is hydrogen peroxide in alkaline medium. The third reaction condition is PCC, that means pyridinium chlorochromate. The moment you see PCC, you should know that it is an oxidizing agent. And where do we use this? To convert alcohol to aldehyde or ketone, depending on whether the alcohol is primary or secondary. So with this information, you can definitely find out what is product 1. This one is treated with mCPBA. What does mCPBA stand for? Metachloroperbenzoic acid. So it is a per acid. When do we use per acid? Generally, we use it to convert alkene to epoxides or ketones to esters. The product 1 has to be a ketone. That means the product formed here has to be a secondary alcohol, which is undergoing oxidation with PCC to form ketone. So product 1 must be a ketone. You can predict all this only when you are thorough with the concepts, when you have already studied alcohols and aldehydes, ketones, etc. Suppose if you don't know these topics, then you better revise the topics and then you can solve the question. The ketone, upon reacting with mCPBA, as I told you earlier, it's going to form an ester. And what is this reaction? It is a named reaction. Generally, the named reactions are disguised like this, and the questions will be asked. What named reaction it is? It is Baeyer-Villiger oxidation. Remember, in Baeyer-Villiger oxidation, we convert ketones to esters using mCPBA. So here we don't have alkene. What do we have? Ketone. That means the product has to be ester. So 1 as a ketone. Do we have 1 as a ketone here? No, it's given as alcohol. That's why it cannot be A or C. Now 2, both of them are given as a cyclic molecules. But is this an ester? No, this cannot be an ester because oxygen is not directly attached to the carbonyl carbon here. That means what? This is a ketone and this is a ether. I'm not even writing any reactions here. Just by identifying the groups, I'm going to find out the answer. So this cannot be the answer. So what is 2 now? 2 is an ester. So go ahead with option D. This is how you can solve question without writing any products. However, for the students who don't know how to find out the products, I'm going to explain in detail now. Watch the video until the end and solve a similar question and master the concept. Let's break down the reactions and find the correct structures of product 1 and 2. So when this cyclic molecule is treated with borane followed by H₂O₂ in alkaline medium, there is a hydroxylation, but it will obey anti-Markovnikovs. What actually happens is the boron will attack the carbon with the less steric hindrance and the hydrogen will attack the carbon with more steric hindrance. Therefore, what happens? Here the hydrogen will go, the boron will go here, which is replaced by the OH. Therefore, what happens here? You are going to get an alcohol like this. And what sort of alcohol it is? A secondary alcohol. Generally, this addition is always a syn addition. The hydrogen and boron will attack from the same side because it is a concerted mechanism. Wherever the boron attacks, that's where the OH will also attack. That means what? If hydrogen is attacking from below the plane, the OH will also attack from below the plane. And what about the phenyl? It will be above the plane. But why hydrogen has to attack from below the plane? It can attack from above the plane. That's why you're going to get enantiomers. Okay, but here the stereochemistry doesn't even matter. Why so? Because the product 1 is an oxidized product of the secondary alcohol. That's why I told you, just by looking at the stereochemistry, don't avoid the question. Here the stereochemistry of the alcohol doesn't even matter, because when this undergo oxidation in presence of PCC, what are we going to get? We are going to get a ketone over here. And although there is a chiral carbon here, you can see it doesn't matter whether it is above or below the plane, because here the product 1 is given as alcohol. The alcohol is not the product here, it is a ketone. Therefore, you can straight away ignore these two products. And then what happens? The formed ketone, when it is treated with mCPBA, it will undergo oxidation, wherein the oxygen of the peroxide will get inserted in this 5-membered ring, and we call this as Baeyer-Villiger oxidation. Now the question is where the oxygen will get inserted. However, from the options we have D as the product, because this is the only ester. This is not an ester, as I told you earlier. But say suppose in the option, if they would have given option like this, then which one to choose? Because you see the ester is over here, right? The phenyl is over here. That means what? The oxygen can get inserted here or here. Then how to decide? It depends on the migratory aptitude of the groups attached over here. Generally, a tertiary carbon is getting migrated. That means what? This is where the oxygen will get inserted. So what sort of product are we going to get? We are going to get a lactone. What is a lactone? A cyclic ester. Cyclic esters are also known as lactones, and that is the product formed over here like this. We don't get this product. This is very specific with respect to mCPBA. Hence, this will be the final product, and that is given as option D. It's always better to follow in the first method so that you can save some time in the exam. If you find any difficulty in understanding the mechanism, how mCPBA is forming an ester, you can drop your question. I'm going to elaborate this in my next video. Thank you for watching this video, and don't forget to subscribe the channel.